Hi, and welcome to the third part of our carburization series. In the last two videos, we have been talking about these samples, these specimens, where we identified carburization. And it was a more qualitative point of view. In this case, we would like to talk about the magic of analytics and what we do to quantify that. In one of our last videos, we have been talking about the ASTM G61 testing. And probably you remember that we did at some point a CPT testing where we used to make a critical pitting temperature test of a grinded surface and how good it is. So what we need to do and what we want to do here is we would like to have a quantitative comparison in between the electropolished surface that we did during this series here and the non-treated version. So in the how it was delivered and in the optimized one. Because we don't know, is there a difference and how big is the difference? However, what we don't want to do is a CPT testing. We want to do a CPP testing. And CPP at this stage means critical pitting potential measurement. So what we don't want to vary is the temperature. We want to keep it constant. And we want to vary the potential. And in order to do it, we need to create specimen out of the untreated sample and the electropolished sample. And what I brought with me here in this system is what we call a CPP testing method system. In this unit, we are preparing specimen of the different parts we would like to test, and we're going to introduce that into that system as a kind of working electrode. So we want to figure how soon and how fast is pitting corrosion happening on a surface. And this occurrence of pitting corrosion in dependence of the applied potential is giving us some indication on the corrosion resistance of the material in general. So what we basically do here in this setup is to introduce the working electrode, which is our stainless steel surface that we prepared, into that unit. Furthermore, we have two counter electrodes in that setup and a reference electrode that we're going to introduce into that part here. What we furthermore do is we keep the temperature stable in that one in order to be sure that we don't have any temperature effects in that measurement. And then we continuously increase the potential between the working electrode and the counter electrode, and we measure it with our reference here. So these are the samples as you actually do them with the specific sample holders. And what we achieved when we did that was that we have an untreated material, such as that here, which is then measured slight electropolishing that we have here against the final electropolishing, which you see here. So we prepared for all these different samples, for all these three, we prepared specimen that we introduced into our apparatus here. And we see that between the perfect electropolishing that you see in the green curve, with regard to the red curve, which is the untreated version, we see roughly a 40% decrease of corrosion resistance, because the red curve has a pitting that is happening much, much earlier compared to the green one. And that's roughly a corrosion resistance difference of 40%. Certainly, the question is, what does that mean to you? Because that certainly depends on your specific application. As said, you might not realize that a lot when it's a gas application, but when it's a liquid application dealing with some critical media, then the root cause or the effect is certainly significant. The root cause at this, that's what we developed, is certainly very simple. It's a miscommunication between two shifts happening, but the effect may become a big deal for your application. So what I wanted to say is, better turn to a trusted source, turn to a supplier which is applying a up-to-date QA and a good visual inspection to the tubing, and who has the source and the potential to also validate the surface quality you need to have in your specific application. So I think within this series of 3 videos dealing about carburization, we were figuring about the root cause, the effects, and also the quantity of the problem that you may become. However, please let us know in case you have questions, and I would like to show you further details in one of the next videos, or if you have questions to this specific one, please let us know and give us a like and a subscribe to the channel. Take care and see you around.